Hello, year 10s. Hope you're well. I can't believe it's the end of the week, and I can't believe that we're just about to finish trigonometry. I feel like this week's gone really quickly. I don't know if it has for you, but it has definitely for me. We're going to look at exam questions and problem solving today. Today's lesson is going to be difficult, but really not that difficult as well. So there's nothing new. It's just about us practicing all the things that we've learned this week, but the questions aren't going to be super tricky, but sometimes we're going to have to draw them out ourselves, or there's going to be multiple things for us to do. But all the things that are going to be in the questions are the things you've been practicing this week. So hopefully it goes all right. Um, I'm not going to do every single question from the worksheet, but I am going to do some of them. If you want to skip forward, I'll write down below which questions I've done in this video. Okay. All right. So if you'd like to listen, yeah, here we go. In triangle RPQ, R to P is 8.7 centimeters, and P to Q is 5.2 centimeters, and angle PQR is 90 degrees. We want to try to find the area of triangle RPQ. So we need to find the area of the whole thing. My hint to you is to draw a diagram. So let's start by doing that. It doesn't actually matter what we do with the diagram as long as we have a 90-degree angle in it. So we know that P to Q to R is 90 degrees, so that means the angle at Q is there, and then you can put the other two letters in any direction that you want. I'm going to put R up there and P down there. R to P is 8.7, and P to Q is 5.2. So what we need to do to find the area of this triangle is we need to find the height of this triangle. So we need to find out how big is it or how long is it from R to Q. I think this is just going to be a a Pythagoras question if I'm going to be honest. So X is going to be, we're going to do 8.7 squared, and we're going to subtract off 5.2 squared, and then we're going to take the square root of all of that. So I'm just going to go over to my calculator, the square root of 8.7 squared minus 5.2 squared, and I end up with x is equal to 6.97. So now I know the height of my triangle, so now I can find the area. So the final part of this question is the area is the base times by the height divided by 2. So we're looking for 5.2 times 6.97 divided by 2. So go back to my calculator, 5.2 times 6.97 divided by 2. And I get a charming answer of 18.122 centimeters squared. And I'll probably just call the answer 18. Okay, and that is our first question on exam questions and problem solving. So it wasn't super straightforward, but hopefully it wasn't also too complicated. All right, stay tuned for the next question. So here's question 3 from the worksheet. It says, shown below is a parallelogram. Calculate the area of the parallelogram. Well, if we want to find the area of the parallelogram, we need the base times by the perpendicular height. And the perpendicular height is the distance from the top to the bottom. My hint is that you need to find or draw a right angle triangle in this parallelogram and find the height. If you look on the left-hand side, where the 7 centimeters and the 50 degrees are, we can turn this into a triangle right there. And if I draw the line straight, I know that that's going to be 90 degrees. And from there, I can go ahead and find the height of this triangle because I know one of the sides is 7 and I know that the angle is 50 degrees. So I'll redraw it over here just to make it a little bit bigger. So this is 50 degrees. This is 7 centimeters. Here's my right angle, and this is the side that I want to find. So I'm going to go ahead and label it. Here's my opposite side, and here is the hypotenuse. So I need to think about what uses O and H. So, oh, there we go, it's so. That one uses O and H. That triangle looks like sine theta is opposite divided by hypotenuse. I'm looking to find the opposite side, so I'm going to multiply the two things together. So side x is the sine of 50 degrees times by 7. Don't forget to put close the bracket in your calculator when you do this calculation. So for that, I got 5.36. So now I know the height of the parallelogram is 5.36. And now that I know the height, I can go ahead and answer the question of finding the area. the area is just going to be the base times by the perpendicular height. So 53.6 centimeters squared. And there you go. That's how you answer question 3. All right, question 5, if you're still listening. The diagram shows 5 straight paths. It's not drawn accurately, so don't get your ruler out and try to measure it. Harry walks along paths A to D and then D to C. Work out the total distance that he walks. So he walks from A over to D, so we need to find that side. And then he walks, I'll do it in a different color, from D to C. So we also need to find that side. Okay, here we go. I think we can totally do this. So this first question, the red one, if you will, I'm going to draw this entire triangle in red. Sorry for my shaky hands there. I've got a red triangle there. I'm going to put an X right here. This is the side that we want to find. We want to find side X. And we also know an angle and another side. So we're good to go. If we're standing at the 55 degrees, the 46 would be the opposite side and the x would be the adjacent side. So we can use our trigonometry to help us out there. We've got SO, CA, and TOA. So we're looking for what uses O and A, so that would be tan. So if we think about what does that triangle look like, the tan of theta is opposite divided by adjacent. So we're looking to find the adjacent side. So if you cover up the letter A, that is O divided by tan. So the adjacent side is opposite side, which is 46, divided by the tan of 55 degrees. So we grab our calculator and put that in. 46 divided by the tan of 55. My calculator says the adjacent side is 32.2 meters. So that's the first bit that Harry walks. He walks from A to D, which is 32.2 meters. Okay, now we're going to go ahead and look at the blue triangle. So we also want to find out how big is it from D to C. And D to C is on this blue triangle here. Okay, so now we're not gonna look at any of the things that are written in red. We're only gonna look at the things that are written in blue. So in this blue triangle, they want me to find this side over here. And I know this angle is 38 degrees. And I also know that this side is 46 meters because they share that, both of the triangles share that side. So I can go ahead and do this question just like I would normally do. The 38 degrees, this side over here is opposite. The 46 is the hypotenuse, and side Y must be side A. Nothing is happening over on the opposite side, so we'll get rid of that. And now we have to decide which uses A and H, and that would be CA. So we're going to use CA this time, and if you want to remember what that triangle looks like, that one is the cosine of angle theta is the adjacent side divided by the hypotenuse. This time we're looking for the adjacent side, and the adjacent side is at the top of the triangle. So if you cover that up, we're going to multiply the cosine times by the hypotenuse. All right, so side A again this time is cosine of 38 times by 46. Now don't forget to put the brackets in your calculator when you do this. Make sure you close the bracket, and we end up with 36.2. So he walks a little bit further this time. So that means his distance from D to C is 36.2. Now the question was, work out the total distance that he walks. So we want to find the total distance, so we're just going to add those together. 32.2 plus 36.2 is 68.4 meters, which actually doesn't seem that far, if I'm going to be honest. That's not that far at all. All right, that's a nice long question worth 6 marks because there's 2 bits of things we have to do there. Hopefully that helps, and let's maybe try another one. Okay, I think this is going to be the last question from me, but like I said before, if you need any help at all, just comment down below in the Google Classroom and I will help you out as best I can. So this question is a non-calculator question, which, I'm not going to know whether or not you used your calculator, but I still think we should talk about it. So it says, given that the sine of 30 is 0.5, so that means if I type in the sine of 30 degrees onto my calculator, it's going to give me an answer of 0.5, which means these two things are the same as each other. They want us to work out the value of x. Okay, so we want to find out how much x is. Let's not even pretend it's a non-calculator question. Let's just try to do the question. So what would we normally start by doing? We normally start by labeling the triangle. So opposite to the 30 degrees is the opposite side, and the 12 is the hypotenuse. And we don't care about the other side because there's nothing happening there. So then we think to ourselves, what uses O and H? We've got so, ka, and toa. And the only one of those that has O and H is sine. So what does that triangle look like? That looks like the sine of theta is the opposite divided by the hypotenuse. Now, in this question, we want to find the opposite side. So if we cover up the O at the top of the triangle, we're going to do sine theta times by the hypotenuse. So let's do that. The opposite side is sine of theta, which is a sine of 30 degrees, times by the hypotenuse. Oh, don't mean to do that. Times by the hypotenuse, which is 12. But what did they just tell us a moment ago in the question? They said that the sine of 30 is actually 0.5. So instead of writing the sine of 30, we're going to write 0.5. So we're going to have 0.5 times by 12, and that just gives us 6. So we can sometimes do our maths in our trigonometry without a calculator, but there's only certain times we're allowed to do that. Okay, this one was really nice because they told us the question, or they told us the value that we were looking for. There are more complicated ways to do that, but we're not going to look at that this week. We might do that when we're back in school. All right, if you have any other questions, please let me know. Other than that, I really hope you have a good day. Okay, bye.